Assalamualaikum everyone. Good day. My name is Mohazir A. Senda, BSCE 2A. So for today's video, I will discuss to you the decision analysis model. So let's get started. Ano nga ba ang decision analysis? Decision analysis is a systematic, quantitative, and transparent approach to making decisions under uncertainty. The fundamental tool of decision analysis is a decision analytic model, most often a decision tree or Markov model. A decision model provides a way to visualize the sequences of events that can occur following alternative decisions in a logical framework, as well as the health outcomes associated with each possible pathway. Decision models can incorporate the probabilities of the underlying state of nature in determining the distribution of possible outcomes associated with a particular decision. These probabilities are not known to the decision maker but are critically important. So these are the summaries. Decision analysis involves identifying the assessing all aspects of a decision and taking action based on the decision that produces the most favorable outcome. In decision analysis, models are used to evaluate the favorability of various outcomes. Decision trees are models that represent the probability of various outcomes in comparison to alternatives. How decision analysis works? Decision analysis allows corporations to evaluate the model the potential outcomes of various decisions to determine the correct course of action. To be effective, the businesses the business needs to understand multiple aspects of a problem to result in a well-informed decision. The analysis entails understanding various goals, outcomes, and uncertainties involved, including the use of probabilities to measure the expected outcomes of various decisions. One of the most important aspects involves framing the problem in a way that allows for further analysis. Framing is typically the first part of decision analysis, and it involves creating a framework to evaluate the problem from multiple perspectives. They can include opportunity statement, action items, and measures of success. Once the framework is established, a model can be developed to evaluate the favorability of various outcomes. Examples of models are decision trees and influence diagram. Decision trees. After creating a framework to evaluate a problem, models are typically used to evaluate the outcomes of various decisions. Models are visual representation of expected outcomes, and they are used to illustrate decision in comparison to the alternatives. By modeling the various expected outcomes and their probabilities, businesses can then select the decision that produces a favorable outcomes. One of the most common models involved in decision analysis is decision trees, which are tree-shaped models with branches represent potential outcomes. Decision trees are used because they are simple to understand and provide valuable insight into a problem by providing the outcomes, alternatives, and probabilities of various decisions. It makes it easy to evaluate which decision results in the most favorable outcomes. Expected value. After a modeling constructed, it is important to find the expected value to evaluate which decision results in the most favorable outcome. Recall the decision trees provide all the possible outcomes in comparison to the alternatives. By calculating the expected value, we can observe that the average outcomes of all decisions and then make an informed decision. To calculate the expected value, we record the probability of each outcome and the resulting value. The formula of the expected value is as follows. EV, or expected value, is equal to probability A times expected payoff A plus probability B times expected payoff A. This formula assumes that the business decision has two outcomes, success or failure. Each outcome can be represented by probability A or B. The expected payoffs refers to the gain or loss expected with each outcome. If there are multiple decisions to be made, a business will calculate expected value for each decision to determine which is most favorable. Real world example. So this is the example. Let's assume that a clothing store is opening a second location and wants to decide whether to open in San Francisco or New York. Opening a location in either city will involve different capital expenditures and demonstrated different rates of success. Before constructing a decision tree, we will need to gather relevant data. So here is the relevant data. Decisions, San Francisco or New York. Probability of success, 40% in San Francisco and 30% in New York. Probability of failure, 60% in San Francisco and 70% in New York. So this is the model, or this is the model. Open in San Francisco, worth 2 million. Probability of success is equal to 40%. Probability of failure is equal to 60% or 0.6. Open in NY or New York, 50 million. Probability of success is equal to 30% or 0.3. Probability of failure is equal to 70% or 0.7. Expected payoff, 15 million and 4 million. 15 million in success and 4 million in failure. In New York, 30 million in success and 10 million in failure. Okay. For each decision, the decision tree also includes numerical data to calculate the expected value. Squares represent decisions and circles represent outcomes. The lines branching from squares are possible choices, while the line branching from circles are expected outcomes. The model also includes the cost associated with opening each locations. To open in San Francisco, the store will need to invest 2 million, while a New York location will require an investment of 5 million. The expected payoff amounts represent the potential revenue if the store succeeds or the potential loss if the store fails. To evaluate the decision is more favorable, we will calculate the expected value for each decision. EV, so like what I've said earlier, EV is equal to probability A multiplied to expected payoff A plus probability B times expected payoff A. EV sa San Francisco, in San Francisco, probability A is equal to 40% or 0.4 times 15 million expected payoff plus probability B is equal to 60% or 0.6 times expected payoff A for 4 million. EV San Francisco is equal to 3,060, $3,600,000. EV New York is equal to probability A 30% or 0.3 times expected payoff A 30 million plus probability A B is equal to 70% or 0.7 times expected payoff 10 million. EV New York is equal to $8,300,000. Then, we must deduct the initial capital expenditure to find the net or gain or loss. San Francisco, 360 million minus 2 million, 2 million is the capital, is equal to $1,600,000. New York, $8,300,000 minus 5 million, the capital, is equal to $3,300,000. After calculating the expected value of each outcome, we can compare them to see which outcome is preferable. In this case, opening a store in New York seems to result in a higher net gain than a mini store in San Francisco. So that's all for today's video. I hope may natutunan kayo. Once again, my name is Mohazir A. Senda. Thank you so much and bye-bye.